Last but not least, we have dilation. Dilation is our only transformation that can change the size of the shape. So dilations are changing of size. So if you have been to the eye doctor and you have had your eyes or your pupils dilated, what happens is they actually make it so your pupils get bigger so that they can see more in your eyes to help decide if you need glasses and what type. So when you're dilating your pupils, they're changing size. If you go into a dark room and you're looking in a mirror and you turn the light on, you'll notice your pupils get really, really small because they're adjusting. They got to get really big to let more light in the dark, and then they shrink to be really tiny when you turn the lights on. So dilation is our change in size. You're shrinking or you're getting larger. So we can just write shrink or grow. And we're thinking in this, we're thinking about our eyes. That is not a good drawing of an eyeball. Okay. So we've got dilation. So if we're dilating figure ABCD by a scale factor of 2, we're actually just going to be making this bigger. Then we want to dilate that new larger figure by a scale factor of 1/3. So you're actually shrinking when you're working with a fraction. So if my dilation, my scale factor, if it is less than 1, you are shrinking. If it's greater than 1, you are growing. So I'll write that as a little note once we have our figure drawn, but I just want to leave us enough space. So if I'm dilating a figure by a scale factor of 2, that means that I'm multiplying these coordinates by a scale factor of 2. So I'm just multiplying each coordinate by that scale factor. So if they haven't set up a table like this for you, which they will not have ever set up this table for you, you need to make it yourself. You need to write out each coordinate in a letter that it goes with. And then you know that when you're dilating it, you are physically multiplying each value of each coordinate by 2. So coordinate A is going to become -2, 6, because we're multiplying -1 by 2 to get -2, and 3 by 2 to get 6. 3 times 2 gives me 6. 3 times 2 gives me 6. So we're just multiplying by 2. 3 times 2 gives me 6. -2 times 2 gives me -4. -1 times 2 gives me -2. -2 times 2 gives me -4. So what I have done is I've created new coordinates. I have created A prime, B prime, C prime, and D prime. So I'm going to just plot these points. So I'm going to actually use a different color so that it doesn't get too confusing. A prime is at -2, 6. B prime is at 6, 6. C prime is at 6, -4. And D prime is at -2, -4. And then I can connect these dots. And I have my figure that has been dilated by a scale factor of 2. Now that we have dilated this figure A, B, C, D by a scale factor of 2, I want us to dilate A prime, B prime, C prime, D prime by a scale factor of 1/3. So now, instead of getting bigger, we're going to actually get smaller. So with this new figure, when I'm going from here to here, because I'm going to add a part of my table, we're going to A prime, prime, B prime, prime, C prime, prime, D prime, prime. We're actually going to multiply this time by 1/3. So I'm going to do -2 times 1/3, 6 times 1/3. And this is a time where it's really, really important to remember that multiplying by a fraction, you need to write it. So if you can't visualize it on your own, if I'm doing -2 times 1/3, I want to make these both fractions and just multiply across the top. So I'm going to get -2/3. So if I did that on my calculator, -2 times 1/3, I'm going to get -2/3, which is the same thing as -0.6666667. So we get -2/3. 6 times 1/3 is 2. 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 -4 times 1/3 -1 1/3. We've got our -2/3 again, and our -1 1/3. So because we're dealing with some fractions, I'm not going to know exactly where to put my coordinates, but I'll know about where to put them. So A prime prime is going to be at -2/3, 2. So about right here, and that's going to be A prime prime. B is going to be at 2, 2. So that's an easy one. Sorry, B prime prime. C is going to be at 2, -1 1/3. And then D prime prime, sorry, is going to be at -2/3, -1 1/3. So we grew our figure and we shrunk our figure. We did a dilation of a scale factor that was a fraction and a scale factor that was greater than 1. So the important thing here to remember is that a dilation changes the size. So a dilation creates a similar image because it's the same shape. Everything in proportion to each other is going to remain the same, but the size itself can change. So your angles are going to stay the same. My ratio of my side lengths to each other are going to stay the same. What's changing is the actual size. So we're growing or getting smaller. But if it was a star to begin with, it's going to be a star after it's dilated. Just like my pupils are circles, when they get dilated, they're still circles. They're not just magically shifting to be squares. So that's our key point of a dilation. If they ask you about perimeter or area of a dilation, I want you to physically draw the dilated figure. Perimeter is changing by the scale factor. So that part is easy. When I had a scale factor of 2 from A, B, C, D to A prime, B prime, C prime, D prime, all that happened is my perimeter doubled. What does not double is the area. And that is something that is super important to take note of. So if I am thinking about perimeter, then I can just think directly of my scale factor, because this 1, 2, 3, 4, 5, 6, 7, 8, it makes sense, because if this side AB is 4 units and I had a scale factor of 2 and side A prime B prime is 8 units, that's exactly doubling. So our perimeter is directly related. Area is different, so just calculate it out. And then last but not least, we have the way we can look at these algebraically. So algebraically speaking, when I dilate an image, all I'm doing is multiplying my coordinates. So when I dilated by a scale factor of 2, I multiplied my coordinates by 2. So we know that all we're doing to go from A to A prime is we just had X, Y, and we went to 2X, 2Y. Same thing if we shrunk. We went from A prime to A prime prime. We just did, no, okay, it's okay, I have white out. Okay. We have 1/3 of what we had, so 1/3 of our X and 1/3 of our Y. That's what that one looks like algebraically. So hopefully this helped a bit with our transformations, both rigid transformations and our one transformation that is not rigid. We have the way we look at everything algebraically. So when you're just looking at the coordinates, so if you're doing a transformation, when you're multiplying, you know you're dilating. If you swapped your signs of your X and your Y, you're looking at your reflections. When we're swapping the location of X and Y and the signs, then we're doing a rotation. And then if we're adding to the coordinates, we know we're doing a translation. So that's everything that we have on our transformations.